Our second concept for today is rotations. So again, we're going to be moving shapes, but rotations do it in a slightly different way. So the idea for rotations here is that we are taking a shape and moving it around a fixed point. So you can almost think about this similar to, I guess, a clock. If you've ever seen a clock with some silly hands on it, the idea is the fixed point is the center of the clock. You might have something that starts off here, and then if you rotate it, it'll end here. So the new image, our rotated image, would be in green. So that's the idea of rotation. You take a fixed point, you just move it basically the same distance around that point, just a fixed number of degrees. So for rotations, there are a few just vocab things to remember. If we rotate something 90 degrees, we can use this R90 rotation, notation, sorry, R90. And the way that we do that is we take our XY ordered pair, and then we change it to negative Y, comma X. So we'll go through some examples for each of these, but the idea is whatever was X is now your Y term, and whatever is Y, the opposite sign of that becomes your X term. Next, if we're going to rotate something 180 degrees, we take our XY ordered pairs, and we go over, and the new coordinates are negative X, comma, negative Y. And then lastly here, we're rotating something 270 degrees of our XY ordered pair. We have Y first this time, and then negative X second this time. So to be clear, a 90-degree rotation brings us over like this. A 180-degree rotation takes us, and it goes all the way down like this. And then a 270-degree rotation takes us all the way over to 9 o'clock on the clock. So that's 90 degrees, that's 180, and that's 270. So example problems for this: if you have something like, let's say another triangle, so P of 1, 1, Q of 4, 5, and R of 5, 1, and we want to rotate this around the origin, so we want a rotation of 90 degrees. Our new ordered pairs for this would be P of negative 1, 1, Q of negative 5, 4, and then R of negative 1, 5. And the way that we got these numbers is for P, we started off with X, Y, and then we changed it to the negative version of our Y, X. And let's color code these. So there's our X, there's our X. Here's our Y, here's our Y. And if we look up top here, for 90 degrees, that's what we used. We had to change it to negative Y, X. So again, our Y term, the negative of it goes first. Our Y term, the negative version of that goes first. The X term stays the same, we just shift it to the Y coordinate. X term stays the same, we shift it to the Y coordinate. So the last thing, a quick sketch, what does this rotation look like? So 1, 1, 4, 5, and then 5, 1 puts us our original here, and then when we rotate it, we end up with negative 1, 1, negative 5, comma up 4, and then negative 1, comma up 5. So this would be the new shape. All right, so as we can see here, we've taken our original points, rotated them around the origin like a clock, and we've gone this way. So that is a 90-degree rotation. The last thing that I should note here for these images on the side is we actually want to go counterclockwise. So the idea is actually the opposite direction. So everything else stays the same, we're just going counterclockwise. So if we start at a point here, we would go from here to here, from here to here, and then from here all the way up to here. So in this case, what we're seeing is we're starting here, we take that rotation left, or we take it left 90 degrees. All right, so hopefully this makes sense for us. I would say the biggest thing for rotations is have this table of the 3 things that we do for rotations copied down. And as long as you have that down and you are doing those